Hey mathematicians, here are your notes for lesson 13.1, day 1. This is going to be our introduction to trig. So quick bell work, we're going to find the length of the hypotenuse in each triangle. So before we can jump into trig, we have to remember a little bit of our geometry. And one of the most important lessons you probably learned in geometry was your Pythagorean theorem, which is a squared plus b squared equals c squared. So we're going to start off today by using something you already know. Now you'll notice in this first triangle, I've got a 30, 60, 90 triangle. If you're not familiar with 30, 60, 90s, they're going to become very, very important in trigonometry. Let's go ahead, use the Pythagorean theorem to find our c, which in this case is on the left side here. I'm going to highlight it so we know what we're looking for. All right, I've got my a of 1 squared, plus b, which is root 3 squared, equals c squared. I'm going to flip it around. C squared equals 1 plus 3 is 4. We're going to take the principal root, so c is just 2. The second important type of triangle we're going to be talking about in trigonometry in our Algebra 2 lesson here is a 45, 45, 90. Now I know it doesn't say 45 up in this other corner, but we know that a triangle's angles have to add up to 180. If we've got 90 accounted for here and 45 accounted for there, it must be a 45, 45, 90. We also know from our properties of isosceles triangles that if one 45-degree angle has an opposite side of 8, the other 45-degree angle also has an opposite side of 8. So even though it only gave us one side, we've actually got two. But unfortunately, it doesn't give us the third. So let's go ahead and plug that into Pythagorean theorem. 8 squared plus 8 squared is 64 plus 64, which is 128. I'm going to go ahead and take the principal root and simplify it so that you don't have to. 8 root 2, making that our length of our hypotenuse. All right, let's get a little bit more fancy now. We're going to start talking about something called trigonometric functions. So the figure at right shows a right triangle. If theta is that little symbol, is the measure of an acute angle of the right triangle, opposite is the measure of the leg opposite theta, adjacent is the measure of the leg adjacent to theta, so right next to, and hypotenuse is the measure of, well, the hypotenuse. And we can start defining the basic building blocks of trigonometry as these 6 items. The first one is sine, S-I-N, theta, sine. And we have to be really careful. We always, when we're working with our trigonometric functions, need to include theta or the angle that we are talking about. We have to be specific. If we don't have that, it's like an incomplete equation. Something will be missing. So sine theta is always going to be equal to the opposite side divided by the hypotenuse. Cosine, C-O-S-I-N-E, cosine theta, is always going to be adjacent over hypotenuse. And tangent, T-A-N theta, is always going to be opposite over adjacent. So notice, using these trigonometric functions and these ratios, we have all relationships accounted for. Well, almost all relationships. Cosecant, spelled C-S-C theta, secant, S-E-C theta, and cotangent have a reciprocal relationship. Reciprocal meaning flipped fraction. So the opposite or the reciprocal of opposite over hypotenuse would be hypotenuse over opposite. Cosine to secant becomes hypotenuse over adjacent, and cotangent becomes adjacent over opposite. Now we have all those relationships accounted for. So let's go ahead and see an example of these. If I ask you to find the values of the 6 trigonometric functions, what I just mentioned up here, for angle theta, the first thing we notice is that we don't have all 3 sides. I could find the ratios with x, but it wouldn't be complete. Fortunately, I have that Pythagorean theorem from earlier, and I'm going to go ahead and use that here. X squared plus 7 squared equals 9 squared. This would be 81/49. X squared. I'm going to have to grab a calculator for that. I don't do that off the top of my head. So 81 minus 49 would be 32. I take the square root and simplify. That I can do in my head. So my x is equal to 4 root 2. And that is my second side there. So after I've solved for my third side, the other thing I want to do is I want to go ahead and label these sides so that they're a little bit faster to work with. If this is my theta, I'm going to go ahead and label the side that is straight across from it as my opposite, the side directly next to as adjacent, and of course the longest side is always the hypotenuse. You don't have to do this, but as you're learning, it can be a good tool to remind you what you're looking for. All right, let's get to it. As I said up above, sine is opposite over hypotenuse. Sine theta, notice we're being specific, is opposite, that was that 4 root 2, divided by hypotenuse, which is 9. Now, I don't want a decimal here. I always want to be exact with my trigonometric values, so go ahead and leave it as a fraction unless you can reduce it. Then, of course, we'd want to go there. Next up, we've got cosine. I always do them down. Cosine theta is adjacent over hypotenuse, so 7 divided by 9. Can't reduce that. And tangent theta is going to be opposite, so that 4 root 2 over adjacent, which is 7. Now, if you're not familiar with it, some of you may have heard of this one. A good way to remember what these trigonometric functions are is our SOHCAHTOA. So sine goes with opposite and hypotenuse. That is our SO. Ka would be our cosine, which matches up with adjacent and hypotenuse. And TOA, which lines up with our opposite and adjacent. So if you're looking for a fast way to remember those and you haven't heard of this before, another great tool for us. SOHCAHTOA. And then, of course, we want those reciprocal trigonometric functions as well. So our reciprocal of sine is cosecant, and we're going to flip it to be 4 root 2 on the bottom. But of course, we don't leave our answer this way. We want to rationalize it. So let's go ahead and multiply both the top and the bottom by square root of 2. When we do that, we get just 8 on the bottom. Root 2 times root 2 is 2. 2 times 4 is 8. And 9 root 2 on the top. Please make sure you're always rationalizing your answers. All right, reciprocal of cosine is the secant. And you might be asking, Miss Bury, why does cosine not go with cosecant and sine go with secant? Here's how I remember it. No two cos go together. You've got sine, cosecant, cosine, secant, and tangent, cotangent. You can't have two cos together. So we can't line these up, we can't line these up. Cosine and secant have to go together. All right, back to this task at hand. Let's flip that. 7 goes on the bottom. We have 9/7. We don't need to reduce or anything there. Cotangent, that is the nice one that kind of matches up a little bit. We're going to flip that. 7 over 4 root 2. We're going to rationalize by multiplying by root 2. 8 on the bottom. 7 root 2 on the top. Just like that. All right, let's flip it over now. So suppose theta is an acute angle of a right triangle. For each function, find the values of the remaining 5 trig functions of theta and write in simplified radical form. Well, you might be asking, Miss Bury, you only gave us one number here. How do we do this? Well, fortunately, because it specifies an angle, we can just go ahead and make a right triangle. We don't care what those specific angle measures are. We just care that we have all 3 to make a triangle and that one of them is a right angle. Then I can label either of the 2 remaining angles as theta, And now I know at least two side values because I have sine. Remember, sine is our so our top value is our opposite side length. Opposite would be root 3, and hypotenuse would be 2, so would be opposite hypotenuse. And of course, using that Pythagorean theorem again, we can find the third side length. I'm going to go ahead and save you some time and tell you it's 1. If you want to check that, go ahead and use Pythagorean theorem to do so. From there, we can find the other 5. I always like to rewrite the sine just because I like to have them in order. Sine, cosine, tangent. No two cos go together, so I'm going to go ahead and say cosecant goes with sine, secant goes with cosine, and cotangent goes with tangent. All right, once I've got my form set up, let's go to work. Sine is just root 3 over 2. Ca would be adjacent, 1 over 2. Tangent would be opposite over adjacent, or root 3 over 1. We can just rewrite that as root 3. Of course, we're simplifying. Cosecant, 2 divided by root 3, except we're going to rationalize that as 2 root 3 over 3. Secant becomes 2 over 1, or just 2. And cotangent becomes 1 over root 3, or root 3 divided by 3. And those are the simple. So as I was saying before in our bell work, these 30, 60, 90, and 45, 45, 90 triangle relationships are so important, and we are going to have to memorize these. There's some great tips and tricks to help remember these. And if you're interested in some of those, come see me. We're just going to go over what they are for right now. We will figure out how to memorize them and get good at that later. So we're going to start out, and I, for the sake of time, already wrote out all of my trig functions. We just have to figure out what they are. The nice thing is, I actually already tricked you into doing a whole set of these. I actually tricked you into doing the 60-degree stuff. So up above, and I wrote it on a different piece of paper so I can show you here, what you've got is a 30, 60, 90 triangle right here. And when I had you do theta for root 3 divided by 2, you were actually finding theta when it is 60 degrees. So we already have this triangle, which means we also have this triangle. It's not drawn to scale here, obviously, because I am not an art teacher, as we all say. So I'm going to go ahead and redraw it here with the correct ratios. So we're going to have 1 across from the 30, the root 3 across from the 60, and the 2 across from the 90. I know that's a little different than the picture up above, specifically because I drew my triangle a little differently. But you can see if we go to do sine, this is going to hold true the same way it did from up above. Sine of 60 degrees is still going to be opposite, root 3, over hypotenuse, which is 2, which is what we did up above. Cosine is still going to be adjacent over hypotenuse, meaning 1/2. And then tangent is still going to be your opposite over adjacent, or root 3 over 1, which is just root 3. So we can go ahead and copy the cosecant, secant, and cotangent over as well. If you remember, those are 2 root 3 divided by, 3. You've got secant of 2, and then of course you've got root 3 over 3. Now that we have the 60-degree triangle, we also have the 30-degree triangle because they're connected. And they're just going to be slightly different. So let's go ahead and do that one. If you want to try this one on your own and then come back, feel free to do that as well. So for 30 degrees, my sine is going to be opposite over hypotenuse. Cosine is going to be adjacent over hypotenuse. And tangent is going to be opposite over adjacent, 1 over root 3, which when I rationalize is just root 3 over 3. If you're looking for a pattern, you're going to notice that your sine and your cosine flipped in the 60s as well as in the 30s there. So they're opposite each other. And then cosecant of 30 is 2. My secant of 30 is 2 root 3 over 3. We just flipped this and rationalized. And then cotangent of 30 is just root 3. And as you'll notice, those are also opposite, your tangents and cotangents. So if you're looking for some cool patterns, they do exist in there and they're pretty easy to find. All right, final one we're going to look at is that 45, 45, 90. And if you remember from our bell work, which I've got back here, we actually did a 45, 45, 90, but instead of having a basic unit for our sides, we had 8. So I'm just going to reduce everything by a factor of 8 to get the side values for my 45, 45, 90. So I get 1, 1, and then my hypotenuse through Pythagorean theorem is root 2. And the cool thing is, because it's 45, 45, not too different, we only have to do this once because it doesn't matter which 45 degree is my theta, all of the ratios are going to be the same. So sine, let's use this one here, opposite over hypotenuse. I'm going to rationalize it to root 2 over 2. My cosine is going to be adjacent over hypotenuse. Also, when I rationalize root 2 over 2, those are going to be the same because obviously they're the same angle no matter what. And then tangent is just going to be opposite over adjacent. 1 divided by 1 is 1. How convenient. Cosecant, flip things around. This is also hypotenuse over opposite, so if you need to think about it that way, hypotenuse over opposite is just root 2. Secant is going to be hypotenuse over adjacent, which would be root 2 over 1, or just root 2. I drew that a little high, sorry about that. And cotangent of 45 is just your adjacent over your opposite. That's just 1 again. So however you need to remember these ratios are going to come in handy. And like I said, there's some great tips out there to use them. But before we get into that, let's just keep going. Let's use some examples and see what we can do here. So find the value for x. So here I have a 30, 60, 90 triangle, and I've got x and 5. Fortunately, I know about those two sides because of my triangle. So I'm going to start off here. I know that that second side across from the 60 is going to be my smaller side times root 3. Look back up here if you need to. My smaller side is 1. My bigger side is 1 times root 3. So if I start down here at 5, I just go to 5 root 3. And then my x, my hypotenuse here, is just going to be twice the length of my first side, meaning this is going to be 10. So just like that, using the ratios and the relationships I have here, I can find that side pretty quickly. Same thing here. I have a 30, 60, 90 triangle. If the leg across from the 30 is 8, and I'm looking for the x, meaning the longer side, I'm just going to multiply that 8 times root 3, because I knew if this was a 1, this would be a root 3. But since it's multiplied, I just multiply it by that root 3. The last one is a 45, 45, 90. If my side length is 12 inches, I know that it has a ratio of 1 to root 2. So if I multiply to get to 12, I'm going to do the same thing with x. So x is just 12 root 2. Pretty fast and simple math, but we do have to remember these triangles and how the ratios work and fit together. But if you have any other questions on your introduction to trig, don't hesitate to let me know.